Every day, whether we're scrolling through a weather app before heading out, adjusting the thermostat at home, or checking the temperature of an oven while cooking, we're quietly depending on numbers to translate the invisible world of heat and cold into something meaningful. Those numbers tell us if we need a jacket, if a road might be icy, or if a recipe will bake properly. But here's where things get surprisingly strange. The exact same physical temperature can show up on a screen as 68, 20, or 293.15, and every one of those values is correct. They're not contradictions. They're three different languages describing the same reality. Today, we're diving deep into Fahrenheit, Celsius, and Kelvin, where they came from, why they coexist, and how each of them shapes the way we experience, study, and understand the world around us. To really appreciate Fahrenheit, you have to go back to the early 1700s, when thermometers were still experimental devices and there was no agreed-upon way to measure temperature. German-Polish physicist Daniel Gabriel Fahrenheit wasn't just trying to create a number scale, he wanted something practical. Early mercury thermometers were fragile, inconsistent, and difficult to calibrate. Negative numbers were especially troublesome, because instruments of the time struggled to register them accurately. So Fahrenheit set out to design a system that would keep most everyday temperatures above zero and easy to work with. He based his 0 point on a reproducible freezing mixture of ice, water, and salt, one of the coldest stable conditions he could reliably create in a lab. From there, he chose additional reference points, including the temperature of ice water without salt and, famously, the warmth of the human body, which he originally measured around 96 degrees. Over time, later scientists refined these values and re-anchored the scale, but the essence of Fahrenheit remained intact. It was built to mirror how people actually experience temperature in daily life. That's one of the reasons Fahrenheit can feel unusually granular. A few degrees change can represent a noticeable shift in comfort, from chilly to mild, from warm to uncomfortably hot. This tighter spacing across the typical human comfort range made the scale especially appealing for weather reports, indoor heating, and day-to-day decision-making. In places like the United States, Fahrenheit became woven into cultural instinct. People intuitively sense the difference between 72 and 75 in a way that feels immediate and personal. To critics it may seem arbitrary, but in practice, the system was carefully tuned to human perception long before global scientific standards existed. Celsius, however, took a very different philosophical approach. Introduced in 1742 by Swedish astronomer Anders Celsius, the system was rooted not in human comfort, but in the predictable behavior of water. At the time, water was central to scientific experiments, navigation, climate study, and everyday life. Celsius wanted a temperature scale grounded in clear, universal natural landmarks. Under standard atmospheric pressure, water freezes at one point and boils at another, two values that could be observed, repeated, and tested anywhere in the world. Originally, Celsius proposed an inverted system, with boiling set at 0 degrees and freezing at 100. After his death, other scientists flipped the scale, giving us the modern structure we know today, 0 degrees for freezing water and 100 degrees for boiling. This layout wasn't just convenient, it was elegantly simple. Anyone could understand and visualize it. The result was a system that aligned beautifully with scientific reasoning and mathematical symmetry. As scientific communication began to stretch across borders, languages, and disciplines, Celsius proved incredibly powerful. It offered straightforward intervals, intuitive reference points, and a logical framework that made it easy to teach and standardize. European nations gradually adopted it for weather reporting, education, engineering, and eventually public life. As the metric system rose to prominence, Celsius naturally expanded with it. Today, most of the world hears temperature through Celsius, whether checking climate reports, reading medical thermometers, or following cooking instructions. Once internalized, the simplicity of 0 and 100, ice and steam, feels almost poetic. Kelvin, however, belongs to a different world entirely. Where Fahrenheit speaks to comfort and Celsius to practical measurement, Kelvin speaks to the fundamental laws of physics. Introduced in the mid-1800s by physicist William Thomson, later known as Lord Kelvin, this temperature scale doesn't concern itself with weather forecasts or kitchen ovens. Instead, it is built around the very nature of thermal energy. Kelvin begins at absolute zero, the theoretical point at which molecular motion stops completely. At 0 Kelvin, particles have no remaining thermal energy to lose. There are no negative Kelvin values because, in physical reality, nothing can have less than 0 energy. Rather than describing how warm something feels, Kelvin measures how much thermal energy a system contains, which is exactly what scientists need when studying heat transfer, gas behavior, or cosmic environments. What makes Kelvin especially elegant is that it uses the same step size as Celsius. The two scales rise and fall in perfect sync. The only difference is the starting line. Water freezes at 0 degrees Celsius but at 273.15 Kelvin, and it boils at 100 degrees Celsius or 373.15 Kelvin. That compatibility allows scientists to convert between Celsius and Kelvin with a simple mathematical shift, while still preserving energy calculations accurately. Kelvin is indispensable in fields ranging from chemistry to astrophysics. When astronomers estimate the temperature at the core of a star or engineers analyze how materials expand at high heat, they turn to Kelvin, not because it's more dramatic, but because it reflects the language of energy itself. So if Celsius is widely practical and Kelvin is scientifically precise, why does Fahrenheit still persist in a few countries? The answer lies in history, infrastructure, and cultural familiarity. Temperature systems spread long before globalization and international standardization. Each region adopted what arrived first or made the most sense for its technology, climate, and institutions. By the time organizations pushed for uniform science standards in the 19th and 20th centuries, Fahrenheit had already been deeply integrated into everyday American life. Switching temperature systems isn't as simple as swapping numbers. It would mean rewriting textbooks, converting industrial equipment, retraining professionals, adjusting regulations, and relearning instinctive associations, things like what feels hot, cold, or room temperature. That inertia doesn't come from stubbornness as much as practicality. People grow up with scales the same way they grow up with languages or measuring units. Once embedded, the system becomes second nature. Each temperature scale survived because it excels at its particular role. Fahrenheit thrives in communication about comfort, the subtle shifts in daily weather that affect how a morning breeze feels or how warm a summer evening becomes. Celsius dominates global infrastructure, medicine, science education, climate research, transportation, and consumer standards. Kelvin governs the scientific backbone of modern research, energy equations, thermodynamics, cryogenics, and space exploration. Today, rather than competing, these three systems coexist, each ruling its own territory. In the United States and a few neighboring regions, Fahrenheit defines weather conversations, HVAC systems, and casual temperature references. Across most of the world, Celsius shapes public life, from meteorology and engineering to environmental monitoring and culinary instruction. Meanwhile, Kelvin works quietly behind the curtain, supporting laboratories, satellites, observatories, and scientific models that help us understand everything from atmospheric warming to the behavior of matter near absolute zero. Think about how differently each of these systems frames reality. Fahrenheit centers our senses and comfort zones. It speaks in the language of how a winter morning bites or a summer day scorches. Celsius frames the world through natural transitions, ice, water, steam, reflecting how physical states change. Kelvin strips away experience altogether and speaks in pure physics, where numbers describe the deep mechanics of energy and motion. None of them is universally superior, because none of them was built for the same purpose. They are tools, and every tool is shaped by the job it was meant to perform. A carpenter wouldn't discard a measuring tape because a ruler exists. A scientist wouldn't abandon Kelvin because Celsius feels intuitive. The value lies not in choosing a single winner, but in knowing which system offers the clearest perspective in a given moment. In the end, Fahrenheit, Celsius, and Kelvin aren't rivals so much as translators, three voices telling the same story from different vantage points. One captures how heat feels on human skin. Another explains how substances behave in the natural world. The third reveals how energy behaves at the most fundamental level of reality. The next time you see a temperature written in a unit you don't normally use, it's not a contradiction or a mistake. It's simply another lens, another way of mapping the same invisible landscape. And perhaps that's the quiet beauty of measurement itself. It reminds us that the world doesn't change just because the numbers do, only our perspective does. Thank you for watching and exploring this journey through the remarkable systems that shape the way we talk about temperature. If you have ideas for future topics or curious questions you'd like us to explore, share them in the comments below. We'd love to acknowledge your contribution in a future episode. If you enjoyed this video, we invite you to check out our other channels filled with more fascinating deep dives into everyday things we often overlook. Don't forget to like, subscribe, and stay tuned for more stories hidden inside the smallest details.